we have a tangent to a circle. We want to look at a tangent. That's a tangent. We have a tangent there as well, as we have previously mentioned in our work. We have a radius. Okay, a radius usually make an angle of 90 degrees with a tangent. Okay, so we have 90 degrees, so that radius is making an angle of 90 degrees with a tangent. So now let us consider an example on this. That's once you see a radius there, you should know that it will make an angle of 90 degrees with a tangent. Suppose this place is given as theta. So definitely this one will be 90 minus theta. Okay. And you know, we have the radius, the radii there, they are the same thing. So, and there is an isosceles triangle. So that place also will be 90 minus theta. So we have a tangent AB, and we have the triangle, a cell triangle AOC. So ACO now is 90 minus theta as well. Okay, because base angle of an isosceles. So we want to get AOC. If we add everything together there, AOC is equals to 180 minus 90 minus theta plus 90 minus theta. That's sum of the angle in a triangle. So 180 minus 180 minus 2 theta. So 180 minus 180 plus 2 theta. So AOC is equals to 2 theta. So we say that the place there is equals to 2 theta. Okay, that is done. Now let's look at an example on this. Suppose we are given 60 degrees there, and we are asked to find M. We should find M. We can simply say that M is equals to 2 times 160. 2 times 60 rather. So M will be equals to 120 degrees. So from that now you can see theta and 2 theta there. Okay, that is about that. There's other way we can do it. Since we know that that is radius and everything there making an angle of 90 degrees with the tangent, can you see that's 90 degrees and the place there is 60 degrees? Definitely the remaining place there will be 30 degrees, of course. So this will be 30 degrees. This will also be 30 degrees. So when you add everything together there, definitely equals to 180. M will be equals to 120 degree. Okay, let's look at alternate segments. We have a chord that divides the circle into 2 unequal parts. We can say that the first part is a minor segment there, and it also divides. You can see we also have major segments up there. So we'll be talking about the 2 segments in these instances with a tangent. So let's look at this in this way. We have a chord that divides the circle into 2 unequal parts. A chord AB, for example, and we have 80 as the tangent. Okay, if the chord AB make an angle of theta, for example, with the tangent 80 in the minor segment, Look at this. This is very, very important. A chord AB make an angle of theta with the tangent in the minor segment. Now, this same chord AB now making another angle in the major segments. You can see now the chord AB making an angle. Okay, now since we have the chord AB making an angle of theta in the minor segment with a tangent 80, so that same chord AB making an angle of gamma, or let's say alpha rather, in the major segment. So what we are going to say is that we will say that the theta now is equals to the alpha. That is the alternate segments. Yeah, that is what is called alternate segment. Okay, now let's move on. Suppose you are given this question, we're asked to find ABC and CAM. We're asked to find the ABC and CAM. To find the ABC, of course, we know that triangle ABC is an isosceles triangle. And we have seen a tangent there. We have seen a chord. Okay, a chord AB. Can you see now? We have to get ACB, because ACB will be the same thing with BAT. It will be the same thing with BAT, and that's also alternate segment because the chord AB make an angle of 70 degree with the tangent 80. The same in the minor segment. So this same chord AB making an angle of 70 degree. Can you see now? The chord AB, yes, making an angle of 70 degree also. So that place ACB also now will be equal to 70 degree, and that's what is called alternate segments. Okay, so we have the triangle ACB, which is an isosceles triangle because BC is equals to AC. I think you can see the sign there. Okay. We also have to say that BAC, the BAC is equals to ABC. That's the base angle of isosceles triangle. The two angles there, they are equal. Okay, base angles of isosceles. Okay, if we know that, then we can say that let this one equals to x. So we have to add up everything here together. X plus 70, which we equals to that's 70 degree because it's alternate to be 80. Okay, so that's 70 degree. Oh, I didn't put it there. That should be 70 degree. Okay, so when we add in triangle ACB, now we add everything together here. So we'll have the 70 degree plus x is equals to 180 degree. That's sum of the angle in the triangle. Okay, so from there now we can say that the 2x is equals to 110, and we can say that our x, okay, is equals to 55 degree. Okay, if the x is equals to 55 degree, so we can say that angle ABC now is equals to 55. That's the first question there, and we have been able to solve it. Now, let us look at the second question here, which is CAM. If you look at the CAM there, we can see that the chord CA make an angle of theta. Sorry, make an angle with the tangent AM in the minor segments. The chord CA make an angle with AM, tangent AM in the minor segments, and definitely the chord CA also will make an angle of B there in the major segments. So in this case, I think we can say that making an angle, yes, A to B there and C to B as well. That's the tip of the chord AC rather. So we can say that now that CAM, angle CAM, will also equals to the 55 degree we have gotten. It's also equals to 55 degree, which is equals to ABC. It's equals to the ABC. So that is about that. Then we move on to the next one. Is the alternate segment. That's the reason. It's called alternate segments. Okay, let's move on to another one. Okay, when you see this type of problem, how do we go about it? Suppose we have a tangent AT, and we also have another tangent BT, and we have a circle with center O. Okay, we have to know sometimes that tangent AT is equals to BT. They are equals to tangents. Okay, we also have to know that angle ATO is equals to BTO. That is another takeaway on this. We also have to note that because we are considering the two triangles AOT and BOT. We also have to note that angle BOT is also equals to AOT, rather is also equals to BOT. That one also need to be noted. So in this case, we can say AOT and BOT, they are congruent. They are congruent triangle. Yeah. Okay, but we'll get to understand this one better. So we can now say OAT also is also equals to OBT, because both are equals to 90 degree there. So these are the things we have to note about this. So it makes the angle AOT and BOT to be congruent. But let's look at more example on this. Suppose we are given this, and we have to find ACB. ATO, angle ATO is 25 degree. I think we are given that. Okay, how do we go about this? Of course, we have to know that OA is equals to OB, and they are radii. They are radii. So to do this, I think we have to consider the triangle. The triangle ATO, we know that is congruent to triangle BTO, as we have stated earlier on this. They are congruent. Please note that. And once they are congruent, so we can say that the angle BTO is also equals to OOTB. you can say the angle OTB is also equals to 25 degree. Yeah, that place also equals to 25 degree, as we have stated earlier on. But that's not even where we are going. But we have to know that angle AOT there, AOT is what we want to get. But we already know that that's 25. And this AOT we want to get. And we already know that OAT is 90 degree. So in triangle OAT now, in triangle OAT, AOT, angle AOT, we want to get it. So it's 180 degree minus 90 plus 25. Okay, that's 180 minus 150. So we have 65. Of course, since we know OAT, if you think how do we get 90 degree, OAT is 90 degree there. I think we have already said that. So that place is 65. Okay, BOT will also be 65. I think that one has been explained earlier on as well. BOT is also 65. Now we can bring the triangle out. Now let's bring this out so that you understand it better. So this place also equals to the BOT. So we can bring the triangle out. Okay, let's look at the way it is now. Of course, we know that this is the angle at the center now. It is 65 plus 65, which will equal to 130. So that is A. That is B. So this is equals to 130 degree. So remember, we want to get the ACB. That's angle at the circumference. If you look at it very well from our first theorem we analyzed, ACB is equals to angle at the circumference, which is equals to 180 divided by 2. And the reason is the angle at the center is twice the angle at the circumference. So angle at the circumference now is half of angle at the center. That's all. So after this, this is the end of the part 2. We'll look at solving past questions. Thanks for being there.